Bismillahirrahmanirrahim. Welcome to Bagh School Online Learning. I am Husnnain Ali, teacher of chemistry, grade 13. Our main emphasis in this video would be regarding the mock 2 examination that the students have appeared in March 2020. Now, for grade 13 students, it is a critical paper as it is of 100 marks. This paper is known as P4. It comprises of 10 questions. So, question wise, we would be trying to solve the whole paper. Initially, there is a statement regarding this paper that is answer all the questions in the spaces provided. So, the students have to attempt this question in the provided spaces. The first question is regarding the solubilities and solubility product. In the first question, part A, subpart 1, the examiner is asking, state how the solubilities of hydroxides of group 2 elements vary down the group. Students, as the syllabus is covered, you know that these things are discussed within our lectures and you are provided with the notes of all the topics. So if you would go through your notes, you would come to see that for the hydroxide of group 2 elements, the solubility increases down the group. If you would write just this statement, you would be gaining 1 mark. Now, question 1, part A, subpart 2. The examiner was asking, explain the factors that are responsible for this variation. So as we know that the hydroxide of group 2 solubilities increases down the group. What are the reasons behind that? The first reason is this. The enthalpy of hydration and lattice energy decreases down the group. Why is this so? Because you would be able to see in your notes the relation of enthalpy of hydration and lattice energy with the radius of the cations of group 2. So, as the hydration enthalpy and lattice energy are inversely proportional to the radiuses of the cations, so both the hydration and lattice energy would be decreasing down the group. So, what is the difference? The difference is that the lattice energy decreases to a more extent than hydration energy or hydration enthalpy. You could go through the formula of both the lattice energy and hydration energy, and you can see from the notes that actually the lattice energy would decrease to a more extent. So thus the final statement comes out to be that the overall enthalpy of solution would become more negative and the reaction would be more exothermic down the group. So the solubility of the hydroxides of group 2 increases down the group. Now these 3 points are to be mentioned in the answer so as to get 3 marks. In the part B, he was asking the solubility of strontium hydroxide is 3.37 into 10 raised to the power minus 2 mole per dm cube at 0 degree Celsius. So, subpart 1 of B part, write an expression for the solubility product of strontium hydroxide. So, if you would see the ionization of strontium hydroxide, you would be getting a strontium ion plus 2 hydroxide ions from the equation. It is a reversible reaction and strontium hydroxide is a sparingly soluble compound. For writing the Kp expression, the concentration of strontium is with the product of the concentration of hydroxide ions. Here the hydroxide ion concentration is squared up as by the law of mass action. So this Kp expression written would be earning you 2 further marks. Now part B, Subpart 2, the examiner is asking, calculate the value of KSP at 0 degrees Celsius, include units in your answer. So this part is comprising of two parts. One is about the value of KSP and the second part is comprising of the units. So for the calculation of the KSP, you just have to write the concentration of strontium ion that is equivalent to strontium hydroxide, as their molar ratio in the equation is 1:1. By putting the value of strontium ion concentration and the hydroxide ion concentration, the hydroxide concentration here you can see uh, it is very imperative that it is two times as the concentration of strontium ion. As the strontium hydroxide dissociates, it would be producing two times more hydroxide ions than itself, as the ratio is 1:2. While the square is coming from the KSP expression, by putting the value comes out to be 1.5 into 10 raised to the power minus 4. The unit, as you can calculate from the expression of KSP, strontium is power 1, strontium ion concentration is power 1, while the hydroxide ion concentration is power 2. The unit would be coming out to be mole cube per dm9. These two answers, one for the calculative answer and one for the unit, would be earning you the 2 marks. This was the first question. Hope this video would be useful for you for further learning and analysis. Thank you.